Hello everyone, today we are going to be demonstrating a cool trick we can do easily with a balloon. We know that Boyle's law describes the inversely proportional relationship between the absolute pressure and volume of a gas. To perform this experiment, we'll need to follow the following steps. First, we need to trap a small amount of air in a balloon and tie a knot. We need to place the balloon in a syringe, and now let us see what happens. When we place the balloon inside the syringe without squeezing the piston, the balloon remains in the same condition due to normal atmospheric pressure. But the moment we close the outlet of the syringe and squeeze the piston, the balloon gets compressed under the increased pressure. Why does this happen? The balloon remains of the same size when the pressure decreases and the volume increases. But when the pressure increases, the volume decreases, making the balloon compress to a smaller size. Now, let's take another balloon and fill it with air. Does the inflation of the balloon violate Boyle's law? When air is blown into the balloon, the volume and pressure inside the balloon increase. Here, Boyle's law is not violated, as the law is valid for a definite mass, whereas in this case, the mass of the air increases when more air is blown into the balloon. Atmospheric pressure tries to compress the balloon, while the force inside the balloon tries to expand the balloon. In a well-inflated balloon, the atmospheric pressure outside the balloon is lesser than the pressure inside the balloon. As the balloon is in equilibrium, this additional pressure is balanced by the pressure due to the elastic force which acts to resist the change in surface area. Hence, it is a compressive force. It is observed that when the balloon is inflated, the rubber surface stretches and creates tension. When the balloon is pierced by the needle in the more concentrated area, it doesn't get popped. But when the needle is brought near the highly stretched area, it gets popped. This results in rapid release of the stored elastic energy, causing the balloon to pop. Now let's take two pieces of tape and stick it to the stretched part of the balloon. This is going to allow us to push a needle straight into the balloon without popping it. Now let us know how this happens. The rubber in the balloon consists of many long molecules called polymers that are linked together. Natural rubber is a polymer made up of isoprene, a monomer with a high degree of flexibility. When molecules of a polymer are chemically attached to each other, it is called cross-linking. These cross-links hold the polymer molecules together and allow them to stretch up to a certain point. When the force exerted on the cross-links exceeds the limit, they will break and the polymer will pull apart. At the darker or thicker spots on the balloon, the rubber molecules are under the least amount of strain. The balloon does not pop when a sharp needle is inserted slowly through its dark spots because the polymers are pushed aside but remain bonded by the cross-links, keeping the air inside. We may also use oil or petroleum jelly on the needle to ensure that it slides smoothly through the balloon. For the next demonstration, we'll need to simply fill the balloon with water, slap on some tape, leaving a square gap, and then pop the exposed part of the balloon within the tape. We have used tape here because it's a little stretchy and it's also waterproof. But why is it essential? Basically, we're adding in new forces which are air current and gravity. These new forces create new turbulence. The water flow will be laminar when water moves smoothly within these layers without mixing. If the hole is made a little bigger, the laminar flow of water can be observed. In the last clip, we saw that a balloon filled with water was popped. When this is observed in slow motion, we can see that the water retains the shape of the balloon for a very short moment, even after the balloon has been popped. This happens due to the inertia of rest. When the balloon is pierced by the needle, it bursts and thus the rubber gets torn apart. Therefore, the rubber is set to motion when the balloon is pierced, but due to static inertia, the liquid inside the balloon remains stationary. Due to this, we can see the water holding the shape of the balloon for a few brief moments. Then, due to gravity, the water falls down, losing the balloon's shape. Thank you for watching.